What's up, everyone? This is Mr. Avila coming to you from Southern California, here with our next video on our series of videos on pre-algebra. Today is video number 12. As always, remember to take out your paper and pencil as you are interacting with me during these lessons. You're not just watching me do the math, you need to do the math too. And I want to let you guys know that if today you are watching this and you are not in my class, welcome. Today you are one of my students. How lucky are you? Do you remember all the rules for adding and subtracting integers? Integers being the positive and negative whole numbers. Well, here are the rules for adding and subtracting integers. They're not perfect, but they're the ones that I've used for many years to help my students understand how to add and subtract integers. If the signs are the same, add the numbers and keep the sign. If the signs are different, subtract the numbers and use the sign of the larger number. And remember that adding a negative is equivalent to subtraction, and subtracting a negative is equivalent to addition. And we have examples there. Also, there are rules for multiplying and dividing integers. We won't be using these too much in this lesson today, but reviewing the previous ones are going to help you for today's warm-up. Please write down these 8 questions, try them out, and pause the video, and when you are ready, unpause and I'll show you the answers. And we are moving on in 3, 2, and 1. I hope you did the problems. Number 1, 4. Number 2, negative 22. Number 3, negative 8. Number 4, negative 7. Number 5, negative 20. Number 6, negative 4. Number 7, 11. And number 8, 3. Congratulations if we were able to do those. If not, ask for help. Watch a couple of videos from a few videos back. Ask somebody to watch them with you so you guys can figure out these rules and understand them. If not, try to reach out to me, and I'll try to help you out as soon as I can. Today, title of the notes is Simplifying Algebraic Expressions. So we're going to be working with algebraic expressions today, which reminds me, do you remember what's the difference between an algebraic expression and a numeric expression? Because today we're focusing on algebraic expressions, so you should know the difference between the two. And here they are. On the left, we have algebraic expressions. On the right, we have numeric expressions. And hopefully you answered that an algebraic expression, Mr. Avila, must have variables. If it only has numbers and we call it a numeric expression, who doesn't know that? We're going to be focusing on algebraic expressions today with doing something that we call simplifying them. Today, I'm hungry. It's burger time. Let's go to a restaurant. Let's go buy some burgers. Here's my order. I'm going to walk up to you. Let's say you're the cashier and I'm the person that's going to order. Here is my order. Excuse me. I would like to order 2 hamburgers, 5 hamburgers, and 3 hamburgers, please. And you're like, wait a second. Couldn't you just have said, what could I have said? Instead of saying 2 hamburgers, I'll have 5 hamburgers, and I'll have 3 hamburgers, I could have just said 10 hamburgers. Why did I make it all complicated like that? Okay? What you just did is you simplified an algebraic expression. Using algebra, we would write that this way. 2 hamburgers, we represent as 2h, plus 5 hamburgers, 5h, plus 3 hamburgers, 3h. We could simplify that and write that as simply 10h. Why did I complicate it? Because I'm trying to teach you some algebra. 2h plus 5h plus 3h is 10h. We call that simplified. We rewrote the algebraic expression in a more compact form. Okay, here's my next order. You ready? I'm getting hungrier. Here we go. I'm going to order 6 hamburgers, 2 French fries, 1 hamburger, and 3 French fries. You're like, wait a second. You could have just said, what? How could I have simplified this order? Okay, let's see if you got it. I could have just said 7 hamburgers and 5 French fries. That would have been much easier for me instead of saying 4 different things. Could have just combined the ones that are the same and set that to be my order. Now in algebra, that would look like this. This is an algebraic expression because it contains variables. 6h plus 2f plus 1h plus 3f. Interesting enough here. When I don't write a number in front of the h, it is understood to be 1h, in this case 1 hamburger, so we don't write that 1 in front of it. So just know that whenever we have a variable by itself here, it is understood that the number in front is a 1. And just as you mentioned earlier, is the same as having ordered 7 hamburgers and 5 French fries. What you're doing is you're simplifying algebraic expressions. Good job. And there's that hidden 1 that we normally don't write. An h by itself stands for a 1. Has a number in front that's a 1. Okay, now I'm going to give you one more complicated order. Try to simplify it. Are you ready? Here comes my order. I am super hungry. 3 hamburgers, 4 French fries, 2 sodas, 8 French fries, 7 hamburgers, 4 sodas. That's what I want. What was my order? Oh, and 1 more soda, just in case I was really thirsty. 1 more soda. So I could have just said, what? Take a minute to look at my order and simplify it. What could I have just said? Okay, moving on. In 3, 2, and 1. What could have been my order simplified? 10 hamburgers, 12 French fries, and 7 sodas. Good job if you were to simplify my order instead of the way I ordered it so complicated. Now, using algebra, the order could be written this way. 3h plus 4f plus 2s plus 8f plus 7h plus 4s plus 1s. Notice at the end, I didn't write the 1 in front of the s. It is understood to be 1s. Simplify, well, we simplify, we combine the ones that represent the same food. So the hamburgers get added with the hamburgers, the French fries with the French fries, and the sodas with the sodas. Combining those, we get 10 hamburgers plus 12 French fries plus 7 sodas. What we did is we simplified an algebraic expression. Very nice job. So what that means, to simplify an algebraic expression, it means to write an algebraic expression in its most compact form without changing the value of the expression. So we try to compact, meaning making it smaller, but in doing so, we don't change the value of the expressions. Like in all of these, like here, my order here is the same as the one that was up here. I'm still ordering the same amount of hamburgers, French fries, and sodas, but we write it in a more compact form, in a smaller form. That's what it means to simplify. You should write that down so you know what simplifying is. So if we were to simplify something like this, just like we had before, we would get 10h plus 12f plus 7s. Now, in case you didn't know, I have an inspiration for putting this lesson together, and it comes from this video. So look up on YouTube, Mad TV Burger Order. Amazing video. Those both actors do an amazing job doing some funny orders. I also want to tack on a little bit of vocabulary. Terms. Terms are the expressions in between the addition and subtraction. So in this case, when I was talking about the burgers, fries, and sodas, each item that I ordered separately, that is called a term. So the 3h, the 4f, the 2s, etc., each are terms. So I would ask you, how many terms are there in this algebraic expression? 1, 2, 3, 4, 5, 6, 7 terms. We have 7 terms in this algebraic expression. So this is an example of an algebraic expression with 7 terms. Those are the expressions in between the addition and subtraction. There's no example of subtraction here. We'll do those in just a second. So given that terms are the expressions in between addition and subtraction, can you tell me how many terms are in each one of these algebraic expressions? Pause the video, write these down, and just write down how many terms. 1 term, 2 terms, 3 terms, 4 terms, 5 terms, 6 terms, etc. Okay, when you're ready, unpause the video. Moving on in 3, 2, 1. Number 1 is 2 terms. Number 2, 4 terms. Number 3, 3 terms. And number 4, just 1 term. Good job. Hopefully you're understanding what it means to be a term. Within a term, we also have something called a coefficient, and that is the number, aka the constant, that is in each term. So in the last one where we had 9x, the 9 here, that is called the coefficient of that term. So we say the coefficient in the term 9x is the number 9. Let's simplify the following expression. So here we have how many terms? Count them up. Hopefully you see we have 1, 2, 3, 4 terms. 1, 2, 3, 4 terms. And when you are ready, let me pause the video and see if you were able to get this answer correct. Simplify. And we're moving on in 3, 2, and 1. Here we have 12AF plus 11H is the simplified form of this algebraic expression. If you got that, you're understanding how to simplify. Proud of you. What you actually did is you combined like terms, where like terms are terms that have the same variable. So you combine the F's with the F's and the H's with the H's. We call those like terms because they have the same variables. Your turn. Please simplify this following algebraic expression. And also tell me how many terms there are in the expression. So write down how many terms there are, and then simplify the expression by combining like terms. Pause the video, and when you're ready, unpause to see if you simplified correctly. We're moving on in 3, 2, 1. Ready? How many terms were there? Hopefully you counted 5 terms. And what do we get when we simplify? 11a plus 9b. Good job. Notice here that we added 10a plus 3a minus 2a. That's where the 11a comes from. The 4b plus 5b gives you the 9b. Simplified, great job. Okay, try this one. Same thing. How many terms are in this expression? And then simplify the expression by combining like terms. Pause the video, write this down, and when you're ready, unpause, and we'll see how you did. Moving on in 3, 2, and 1. Are you ready for the answer? I hope you're doing these. You're not going to learn math just by watching. You have to do it. Okay, how many terms are there? Hopefully you said 3 terms. Correct, 3 terms. And what did you get for your simplified answer? Negative 2x plus 8y. Did you get that negative? I hope you didn't just do 7 minus 5 gives you 2, because in this case, it was 5 minus 7, which is negative 2. So our answer is negative 2x plus 8y. The 8y, poor guy, didn't have any like terms. We just brought it down. Okay, try again. Throwing in a little bit more negative, And also hint, terms with no variables are considered like terms as well. So count how many terms there are, simplify the expression, pause the video, and when you're ready, move on to see if you simplified correctly. And we're moving on in 3, 2, and 1. Are you ready for the answers? Okay, how many terms are there? 1, 2, 3, 4 terms. There are 4 terms here, negative 2, 5x, minus 6, and the 2x. 4 terms. What did you get when you simplify? Hopefully you arrived at negative 8 plus 7x. Negative 2 minus 6 is negative 8, and 5x plus 2x is 7x. Negative 8 plus 7x. We simplified this algebraic expression. We wrote the expression in a more compact form, still making sure that the expression is equivalent to the one that we started with. Simplified. Great job, everybody. Time to practice. Be careful with those negatives. That's what I'm most worried about. I think you understand which ones get combined. It's when it's dealing with those positive and negative numbers that I'm most worried about. Please write these down, pause the video, do all 8 of them, and when you're ready, unpause the video, and I'll show you the answers, and we'll see how you did. We're going to move on in 3, 2, and 1. No peeking. No peeking at the answers until you've done the 8 that I just showed you. I trust you, though, so let's move on. Here are the answers. Answers for numbers 1 through 8. Check them all, please, one at a time. Carefully that you have them correct. If not, please ask for help. Reach out to somebody around you, reach out to me, and we'll help you out as soon as we can. Great job. Where's the guy there? Well, there it is. Double thumbs up for you. We're going to end with a little challenge. See if you can do this on your own. I want you to try to create your own algebraic expression with 6 terms. So let's have 6 terms. And that it simplifies to 25x minus 3y. Okay, so try to invent your own. And then let me know, see how you did. With that, we're going to be wrapping up this lesson. Today, we learned how to simplify algebraic expressions by combining like terms. We covered the vocabulary terms, like terms, coefficients, and what it means to simplify. Thank you so much for watching this video. I'm proud of all of your work. If you happen to have a math question or you're in a math class and would like a lesson presented to you on a math topic, please make sure to reach out and I'll try to put together a video for you as soon as I can. With that, that wraps up today's lesson. I want to thank you again and we'll see you in the next one. Bye.